These problems are investment problems that are compounded continuously. Well, that would be cool. All right, so here is the formula. And as you read the problem, just identify each part of the formula. The one thing that you do need to be aware of is this E is not a variable, it's a constant. Kind of like pi. E is about 2.718 and it goes on forever. So E is a constant. You're never going to replace E, but you're going to find the other variables. Okay, so right up here, Nicole invests, well, whatever she's investing, that's the principal amount in a retirement account with a fixed annual interest rate. Rate is R. We're going to convert that 5% to a decimal. So we just, if you on your calculator do 5 divided by 100, you'll see that that's 0.05. That's the rate. And then in this case, it tells us the time, 14 years. Well, we can take those things and plug it into the equation. So we don't know what the account balance is going to be, but our principal amount is $5,569 multiplied by e to the 0.5 times 14. And guess what? You can just type that right into the calculator. So I'm going to type 5569, the second button, the LN button, and that brings up e to the, and in parentheses, I'll type 0.5 times 14 and then close the parentheses. Oh, this would be cool. $6,107,150 and about 6 cents. Could you imagine after 14 years with only a $5,500 investment having $6 million? That would be cool. But that's how that works. If you can find something compounded continuously, that would be a very sweet deal. So now we have one where we need to find how long will it take. We're going to be finding the time. Again, we're going to plug all these values in. She invests $28.97. That's the principal. Interest rate 9% or 0.09. And the account reaches, oh, well, that's not very much. So my guess is the time is not very long. So $4,543.40, and that's going to equal the principal. So $28.97 times e to the 0.9 times t. Well, notice we need to get this by itself, and then we're going to have to get the t by itself. But t is part of this e portion, but $28.97 is attached by multiplication, so we're going to divide both sides by $28.97, and when we type in 4543.40 divide by $28.97, we are going to get this value 1.5683. Some more stuff. I'm going to hit store on the calculator, store, enter, and now those cancel, leaving e to the 0.9t. Okay, well, remember the undoing of an exponential is taking the log, and because it's base e, we're going to take the natural log of that 1.5683, and the number kind of goes on. We're going to take the natural log of e to the 0.9t. All right, when we do that, notice we can use the properties of logarithms. So this exponent is now going to get brought down in front, 0.9t. Well, the natural log of e, if you type in natural log and then hit the second button, natural log again, and type 1 for the exponent, close parentheses, enter. This cancels to 1. So this got brought down in front. The ln of natural log gets canceled. So we're left with 0.9t, and we still have natural log 1.5683 ... Remember, that's stored into the calculator. And now to get t by itself, we just divide 0.9. So in your calculator, you're going to take the natural log, hit second store, that pulls up the stored amount, close the parentheses, divide that by 0.9, and what you have is t is equal to 0.49999, so 0.5. We're talking about how long, and remember, t is in years, so 0.5 is about a half a year. All right, now we're going to go on to another one. Julie invests some money in a savings account with a fixed annual interest rate. We don't know the rate this time. It's compounded continuously, so we know we're going to use this formula. And the time is 10 years, and they give us the balance. So here's the A. So instead of A, I'll put 12,457.07 is equal to, the principal is 6186 times E to the, this time we don't know the rate, but we do know the time, which is 10 years. Oh, well, this is going to be very similar to what we just did because the missing variable is in with the exponent. So we're going to have to take the natural log again. But before we do that, notice 6,186 is attached by multiplication. So we're going to divide both sides. So in the calculator, 12,457.07 divide by 6186, enter. I'm going to store that again. All right, this cancels, leaving e to the 10r, and this side over here equaled 2.01375 ... Again, we're going to have to take the natural log. I should do that in a different color. The natural log of both sides. And when we take the natural log, remember, we can use properties of logs. That's going to come down in front. So that now cancels there. Well, the natural log of e cancels to 1. 1 times 10r is just 10r. And then 10 is attached by multiplication. So we're going to take that natural log of 2.01 ... that's stored in our calculator, and we're going to divide it by 10. So I'm going to type in natural log, second store, to pull up that number, close the parentheses, so right parentheses, divide 10, enter, and we get R, because the 10s cancel, 0.0, it's 6999, so 0.7, but we want to know, we want to convert that decimal back to an interest rate, so just multiply that by 100, and we get 6.99%, or that was at 7% for 10 years. It took, for this balance, it only took 7 years for that amount to double at that interest rate. All right, one more. Dan invests a sum of money in a retirement account with a fixed annual interest rate, so we know the rate, we know the time, we know the account balance. We don't know the P this time. So we have the account balance, $18,475.62. We don't know the P, but we do know the rate is 9%, so 0.09. The time is 20 years, so this is 0.09 times 20. Notice we want to get P by itself, and all of this stuff, E to all of that is attached by multiplication, so we can divide both sides by E to the 0.09 times 20. So E to the 0.09 times 20. And guess what? If you're really careful, you can plug that into the calculator, and that's going to give you the answer for P. So this is how you would go about doing that. Left parentheses, 18,475.62, right parentheses, divide. Left parentheses, the second button, LN, and that gives you the caret button, and then left parentheses, 0.09 times 20, close parentheses, which means right parentheses, enter. And that tells us that the initial investment, the initial principal, was $3,053. And, well, it's 99999, so that's actually going to round to $3,054.00, and that's the principal. And I need to go back here. I think on one of these, I may not have. There we go. I knew that seemed odd. I think that's going to be 5 years right there. So I'm going to go ahead and type that in case some of you caught that and I had not. So the natural log of that 1.5683 divided by 0.09. Yeah, that's about 5 years. All right, so that's it. I'm glad I ended up catching that, even though I initially made that mistake. But there you go.